VAM, VAM, VAM method or penalty method. Penalty method. Penalty method. సార్ శ్రీనివాస్ సార్ అండి. సార్ నేను మ్యాథమెటిక్స్ సార్, ఎల్పీపీది ఇంగ్లీష్ మీడియం. అది మేము చెప్తున్నాం కదా సార్, ఆ వీడియోలు మీరు చూసుకోవాలంటే ఎట్లా సార్? నాది మ్యాథమెటిక్స్ ఎల్పీపీ, లీనియర్ ప్రోగ్రామింగ్ ప్రాబ్లం, 5th సెమ్ బి. చెప్పండి. ఓకే సార్. ఇంగ్లీష్ మీడియం నేను కూడా చెప్పాను, నాది ఏదో గాట్ ఇట్ అని వస్తుంది కదా రికార్డింగ్, అది రాలేదు సార్. ఓకే సార్, థ్యాంక్ యూ. నా పేరు అప్పారావు సార్, ఇదే నా నంబర్, ఫోన్ నంబర్. మ్యాథమెటిక్స్. థ్యాంక్ యూ. మ్యాథ్స్. So, procedure. The algorithm for them. Algorithm for them method. Algorithm is step by step procedure is called algorithm. So step 1. Step 1. For each row of the transportation table, each row of transportation table, TP is transportation problem table. Identify the smallest. Identify the smallest and next smallest. Next smallest. Next smallest. Or minimum, as we can say. Next smallest. Cost. Determine the difference between them. Determine the difference between them. Difference between them. Difference between them. For each row. For each row. Vice versa column. Vice versa. Or step 2. Step 2. Identify the row or column. Identify the row or column. With the largest penalty among with the largest penalty among them. Among them, largest penalty among the rows and columns. Hello? No, slide 20. Okay, sir. Thank you very much. Among them, rows and the columns. Rows and columns. Columns. If tie occurs, use any arbitrary choice. If tie occurs, use any arbitrary choice. Any arbitrary choice. So Xij minimum cell cross the higher round with column. Let the greatest difference between the correspondence ith row and let Cij be the smallest cost. Choice. The greatest difference between the corresponding ith row and let Cij be the smallest cost in the ith row. Allocate the minimum feasible amount. Xij equal to minimum of Ai, Bj, Ij cell and cross the ith row or jth column in the usual manner. So step 3. Step 3. Recompute the columns and rows difference. Recompute. You compute the rows and columns. Columns. Rows and columns. Rows and columns. Rows. Rows and columns. Difference means difference. Difference is nothing but penalty. Difference is penalty. Penalty. For the reduced transportation table. For the reduced transportation, table, reduce to transport table, and go to step 2, and go to step 2. Go to step 2. Repeat the procedure until the requirement are satisfied. Repeat the procedure until all the requirements are satisfied. All the requirement are satisfied. Satisfied. Next, all the requirements are satisfied. Using this method, we'll solve one problem. That is Vogel's approximation method. Example. Problem is D1, D2, D3, D4. D1, D2, D3, D4. O1, O2, O3. O1, O1, O2, O3. Here 50, 50, here 50, here 100. Next here, this is the requirement. Availability. Availability. Requirement is nothing but demand. Availability is nothing but supply. Next here 30, 40, 60, 70. 60, 70. Here 15, 0, 15, 0, 20, 10. Next 12, 8, 11, 20, 9, 16, 14, 18. Okay. So we need to follow the steps of algorithm on step by. What is the least element? Least element is here 0. Next least element. Least element or small element, smallest element or minimum element. Next is 10. 10 minus difference, 10 minus 0 is 10. Here 10. Next, what is the least element here? 8. Next least element is 11. 11 minus 8 is here 3. Next, here least element is 14. 9. Next least element is 14. Difference is 5. Okay, here. That is row we did. Similarly, column. These are all known as RP. RP means row penalties. Next is CP means column penalties. So row penalties, column penalties, also known as this. Least element is 9. Next least element is 12. That means 3. So next least element is 0. Next least element is this is 8. Next least element is 11. Next least element is 14. Difference is 3. Least element is 10. Next least element is 18. Difference is 8. Here we need to observe in rows and columns. First, we need to observe the highest penalty. Highest penalty, how much is there? 10, 3, 5. Here 3, 8, 3, 8. Here highest penalty is 10. So in this row, highest penalty. In this row, what is the least element here? Least element is 0. Here next, here 40 is there, 50. What is the minimum? Minimum is 40. So we write here 40. We allocate in the cell 40. So cross the 40, 0. So 40, 50 minus 40 is 10. So here 0 we got. I have to cross the column. So next step. Go to next step. That is and also we need to first of all sigma ai that equal to sigma bi is nothing but so supply equal to demand 200 equal to 200, right? Next 200 equal to 200, so m plus n, m rows, n columns minus 1, uh, m 3 rows plus 4, m rows, n columns, 4 plus 3, 4 plus 3 minus 1. Means within the 6 steps exactly solution. So next step, step 2. Here D2 is gone, D1. Here D3, D4. Next 15, next 20, here 10, next 12, 11, 20, next 9, 14, 18. So this is this 30, it is 60, this is 70, here, here 10, next 50, next 100. Now, as usual, step 2, we need to calculate penalty. The least element is 10, next least element is 15, this is 5. Least element is 11, next least element is 1. Least element is 9, next least element is 14, 5. Next least element is 9, next least element is 3. Least element is 11, next least element is 3. The least element is 10, next least element is 8. You have to check your highest penalty. What is there? 8. So here least element is 10. We have to allocate the 10. Here 70 is here 10. 10 is the least element. We have to allocate 10 in the cell. Then we got 0. This becomes. So we need to cross this row. So here 10, 70 minus 10 is 60. Next, step 3. Step 3. Step 3. Here, T1. One random. T1, T3, T4. Next, 12, 11, 20, here 9, 14, 18, 14, 18, 14. Here this is 50. This is 100, 30. Here 60. Here also 60. So again penalty we need. What is the least element? 11. Next least element is 12. So 12 minus 11 is 1. Next least element is 9. Next least element is 14. This is 5. Least element is 12. Next 9. Next element is 3. Next least element is 11. This is also 3. Least element is 18. This is 2. So what is the highest penalty? Highest penalty 5. So in the 5, least element is 9. 30 here, 100. So we have to allocate 30 in the cell. Cell here 30 minus 30, 0. Here 70. The 100 minus 30 is 70. So the 0 we got. So we have to cross this box. Next, step 4. Step 4. Here step 4. Here D3, D4. D3, D4, 11. 14. Here 20. Here 18. 60. Here 60. Here 50. Here 70. So again, what is the least element here? 11 here. Is this 9. Now here 14. This is 4. Next here 3. Here 2. What is the highest? Highest is 9 penalty. So what is the least element here? Least element is 11. Here least 50, 60. Here demand is 60. Supply is 50. We have to take here, allocate 50 in the cell. So 50 minus 50 is 0. So you have to cross this column. Next. Next step 5. 14, 18, 70. Okay, 18. 14, 18. Next. Here 50. We have to 50 minus 60 minus 50 is 10. So next step 14, 18, 10, 60, 70. Yeah, 14, 14, 18, 10, 60, here 70. So, so here what is the least element? 10. Here, we have to take 10 inside, 0. Here, 70 minus 10 is 60. So we have to take step 6, step 5, step 6, step 6. Here, 18 is there. I have to allocate 60. Here 60. Here 60. Here 0. Here 0 is got. So 8. So total cost. So total cost. Total cost. Total cost. Total cost. 6 positive independent allocation. This ensures total cost equal to 0 into 40 plus 10 into 10 plus 20 into 50 plus 20 into 50 plus 9 into 30 plus 14 into 60 plus 18 into 10. That equal to, so 2390. 239. 239. Next. Next, we will discuss next Modi method. Modi method. Modified distribution method or Modi method. Modified distribution. Modified distribution method or Modi method. Modi method. Modi method. Modi method. So algorithm for Modi method. For Modi method. Algorithm for Modi method. The following steps are followed to find the optimum solution of transportation problem. Step 1. Step. Find an initial feasible solution consisting. Find IBFS, initial feasible solution consisting of m plus n minus 1. M plus n minus 1. Allocations at independent positions. Allocations. The independent solutions. Independent solutions. Independent positions using any of the three methods. Independent positions using any of the three methods. Using any of the three methods. What are the three methods? Northwest corner method. Next, least cost method or matrix minimum method, or Vogel's method or penalty method. These three methods. So step 2. Step 2. Check the number of basic cells. Check the number of basic cells. Basic cells means occupied cells. OCCUPIED. Occupied cells. Occupied cells. If there are less than m plus n minus 1, n plus n minus 1. There exists degeneracy. There exists degeneracy. There exists degeneracy. Step 3. Step 3. For basic cells, calculate for basic cells, calculate basic cells, calculate UI for rows, UI for rows, VI for columns, for columns, for columns, columns. By solving the system of equations, by solving the system of equations, solving the system of equations, solving the system of equations, Cij equal to Ui plus Vj, by assuming by assuming one of Ui's or Vj's is zero. Next, 0. Step 4. Step 4. For non-basic cells, for non-basic cells, calculate opportunity cost. Opportunity cost by using the relation by using the relation Dij is nothing but penalty equal to Ui plus Vj minus Cij This is cost. Vij is the penalty. And enter them in upper right corner. Enter them in upper right corner. Right corner. Upper right corner. Upper right corner of cells enclosing enclosing in parenthesis so data. Step 5. Examine the sign of each Dij. Examine the sign of each Dij. Sign of each Dij. First one. If all Dij, if all Dij less than 0, then the current basic feasible solution, then the current basic feasible solution is optimum one. Optimum one. If at least one Dij, at least one Dij less than 0, select the non-basic cell. Non-basic cell. Select the non-basic cell. Select that one. Having largest positive opportunity. Having largest positive opportunity. Cost among all. Non-basic cells to enter the basis. Non-basic cells to enter the basis. Enter the basis. Step 6. Step 6. Allocate n amount of theta. Allocate theta to the entering variable cell as entering variable cell. Variable. Variable cell. Variable cell. Identify a loop that starts. Identify a loop that starts and ends. That starts and ends. Starts and ends. All the entering variable cell. Entering variable cell. All the entering variable cell. For the availability and requirement limits. For availability and requirement is nothing but demand and supply. Requirement limits to remain satisfied. Limits to remain satisfied. Remain satisfied. We must alternate between subtracting alternate between subtracting and adding the theta, between subtracting and adding theta, adding theta at the successive corner of the loop, at the successive corner of the loop, successive corner of the loop. Step 7. Step 7. Assign a maximum value theta. Maximum value theta in such a way that the value of one of basic variable, value of one of basic variable, dv, means basic variable, becomes 0. Becomes, and the other basic variable remain non-negative. The remaining non-negative. Non-negative. The basic cell whose allocation, the basic cell whose allocation, whose allocation has been reduced to 0. To 0. Reduced to 0. Reduced to 0. Reduced to 0. Leaves the basis. Basis. Step 8. Step. Return to step 3. Step 3. Return to step 3. Repeat the process. Repeat the process. Repeat the process. Repeat the process. Process. Until optimum basic. Optimum basic. Optimum basic. Feasible solution has been obtained. Solution has been obtained. Okay. Okay. So using this procedure, we'll solve one problem. Optimal test. optimality test. Yes. Step one. Step sell and cost values of allocation boxes. Cost values of allocation boxes. Boxes. Sell cost. Cost. 2 6. We have 0, 5, 8, 4, 15, 9. So consider that U1, U2, U3. These are the V1, V2, V3, V4. So here, what we have a formula Cij, Cij equal to Ui plus Vi. So here U1 plus V1 that equal to 2. Next U2 plus V2, V2 plus V2 equal to 0. U3, U3 plus U3 plus V2, U3 plus V1, U3 plus V1 equal to 5. U3 plus V2 that equal to 8. U3 plus V3, U3 plus V3 that equal to 15. U3 plus V4 that equal to 15. 9 that equal to 9. So here U3 plus V4 9. So that implies U1 equal to 0. So U3 equal to 0. Let U3 equal to 0. U1 equal to -3. U2 equal to -8. V1 equal to 5. V2 equal to 8. V3 equal to 15. V4 equal to 9. Step 2. Step 2. Sell and cost values of non-allocation boxes. Sell and cost of non-allocation boxes. Location boxes. non-allocation boxes. So Dij is penalty. Ci is the here. Dij equal to penalty. Dij in the penalty. Cij equal to cost the element of non-allocation allocated. The element of non-allocated cost, the element of non-allocation, non-allocated. Um, so optimality condition, optimality condition, optimality condition. Optimality condition. Dij, Dij, Dij that equal to Cij minus ui plus vi. Formula. So this box 3, 2, 11 minus 1, 7, 1, 1, 4, 6 minus 1, 1, 0, star. Here, D12 that equal to C12 minus U1 plus V2 that equal to 3 minus 3 plus 8 that equal to minus 2 less than 0. D13, D13, C13 minus U1 plus V3 that equal to 11 minus 8 plus 15 that equal to minus 1 less than 0. D21, D21 that equal to C21 minus U2 plus V2 that equal to 1 minus 8 plus 15 minus 8 plus 15 that equal to 4. So D14 1, D23 similarly D23 minus 1 which is less than 0. D24 that equal to 0. So here some values of Dij. Here some values of Dij. Dij less than 0. The existing IBFS, the existing IBFS is not an optimal solution. Is not an optimal solution. Optimal solution. So go to modeling solution. Go to modeling. Step one. Step one. Cell values allocation process. Cell values allocation boxes. Boxes. Allocation boxes. With the positive, with the negative cell box values. With the negative cell box values. Cell box values. Also, here minus theta. Here minus theta. 6 minus 2 plus theta. 1 1 plus theta. 4 minus theta. Plus theta. Box. Here maximum values. Maximum values. Maximum values. Minus 2 comma minus 1. So negative minus 2. So minimum 4 minus theta, comma 6 minus theta. That implies minimum 4 comma 6. That implies theta equal to 4. So again apply automatic test. So again apply optimality test. So thank you very much. Today I'm leaving. Close the class. Thank you very much.